You are welcome to Global Learner Solution. Please subscribe, like, share, and comment. From where we stopped last time, the part 1 of modular arithmetic. Now we are taking modular addition. Let's take some examples. Let's take some examples. Okay. Evaluate 5 modulo 6 plus 7 modulo 6. Now let's see. This is very simple. 5 modulo 6 plus 7 modulo 6. 5 plus 7, what does that give us? That gives us 12 modulo 6. Now 6 goes into 12 how many times? 2 times. And what's the remainder? The remainder is 0. So 12 modulo 6 is same thing as saying what? 6 times 2, giving us that particular 12. And there's nothing remaining. Plus what? Plus 0 modulo 6. So the answer remains 0 modulo 6. If I have another example here, let's say these are A, now the B. Okay, 20 modulo 5 plus 3 modulo 5. What does that give us? Let's look at the big part of it. These are A, which says 20 modulo 5 plus 3 modulo 5. What does that give us? 20 plus 3. Okay, so we can now have 20 plus 3. All of them having the same modulo. That's modulo 5. 20 plus 3 gives us 23 modulo 5. And that's equals to 5 going to 23 how many times? That means we have 5 times 4 giving us 20. And then what are you going to add to 20 to give us 23? That's 3 modulo 5. So the answer remains 3 modulo 5. Very simple. 3 modulo 5. So addition of modulo is very simple. Let me give you another one. Can you try this one? Try this one. Let's look at the C part. Okay, do it by yourself or you continue. So if I have C, 7 modulo 3 plus 9 modulo 3. What does that give us? Then the solution of the C, we now have 7 modulo 3 plus 9 modulo 3. 7 plus 9, that is the solution for 7 plus 9 modulo 3. And 7 plus 9 gives us 16 modulo 3. And then 3 goes into 16 how many times? We can say equals to 3 times 5. That is the closest one, that is 15. And what's the remainder? The remainder is 1 in the modulo 3. So the answer is that remainder. Don't forget that. The answer we are after here is what? The remainder. So that is 1 modulo 3. Is that okay? Alright. Okay. Let's take another example. Try this particular one. Very simple. Try this example. Or let me take as a little work for you. Okay, let's take the D part. 25 modulo 8 plus 30 modulo 8. Can you try that? Okay, what's your answer? Let's move on. So 25 plus 30, all the modulo 8. What does that give us? They give us 55 modulo 8. 8 times what is closer? Is closer to 5. What do you think? Can you give me answer? If we take 8 by 7, that will give you what? That will give us 56. Okay. So 8 by 6, that will give us 48. That means I can now say 8 times 6, that is 48. What will you add to give us 55? That means we add 7 in modulo 8. So what's the answer? The answer remains 7 modulo 8. I think that's very simple. Okay, thank you for watching. Now try this. 21 modulo 7 plus 8 modulo 7. What do you think is your answer? I know you can do that. Now quickly, let's move to modular table. That is modular addition table. Modular addition table. And we have taken notice of this. Very important. Okay, try it. And then modular addition table. Okay. All the elements of a particular modulo must be less than that modulo. For example, elements of modulo 5 include 0, 1, 2, 3, and 4. That in modulo 3 include 0, 1, and 2. So in modular addition table, let's take one example quickly. Okay, construct addition table in modulo. That's addition table in modulo 5. Okay, addition table in modulo 5. So this is how you are going to do. First of all, write the modulo so that anybody that sees this will know the modulo you are dealing with. And then addition. That means here you put plus. And I've told you the elements of a particular modulo, like modulo 5, we have 1, 2, 3, 4. And then also here we have 0, 1, 2, 3, and 4. This is what you are going to do in modular addition. Very, very simple and quickly. Okay, we have this 0, look at my hand, 0 plus 0, giving us 0, 1 plus 0, 1, 2 plus 0, 2, 3 plus 0, 3, 4 plus 0, 4. And now you start again, 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1 is 5. And you're not supposed to keep that 5. So 5 goes into that 5 how many times? 1 time, remainder 0. Now 0 plus 2, 2. 1 plus 2, 2. 1 plus 2, that gives us 3. And then 2 plus 2, giving us 4. 3 plus 2, giving us 5. You cannot keep that 5 because all the elements, the members of the modulo should be less than that modulo. So having 5 goes to 5, 1 remainder 0. 4 plus 2, 6. 5 going to 6 how many times? 1 time. Remainder. Only the remainder that we are keeping here. 0 plus 3 giving us 3. 1 plus 3 giving us 4. 2 plus 3 giving us 5. You have no right to keep that 5. If you keep that 5, that will be very, very wrong. And then that gives us what? 0. 3 plus 3, 6. 5 into 6, 1 time remainder 1. 4 plus 3, 7. 5 into 7, 1 time remainder 2. Now we go again, 0 plus 4, 4. 1 plus 4, giving us 5. And you don't keep that 5. That gives us 0. 2 plus 4, 6. You keep 1. 3 plus 4, 7. 5 into 7, 1 time remainder 2. And then 4 plus 4, what does that give us? 8. 5 into 8, 1 time remainder 3. And we're looking at this 0, 1, 2, 3, 4, 1, 2, 3, 4. You see that what? Like this, I have 0, I have this 1, I have 2. Alright, so that's how to do modular table when it comes to addition. Now try modulo 4. Try modulo 4. Thank you very, very much, and God bless you.